In this video, we're taking a closer look at Visual Effect Graph in Unity 2019.3 and exploring fundamental ideas and concepts to help you get started designing visual effects in Unity. In some of our previous videos, we've introduced Visual Effect Graph and explored manipulating textures to create cool-looking effects. In this video, we're going to look at how we can combine multiple techniques to create a great-looking multi-layered effect. If you're unfamiliar with Visual Effect Graph or visual effects in general, consider watching the previous videos linked below, as they will help you understand some of the concepts discussed in this video. We're using the scene included in the Visual Effect Graph spaceship demo for these videos. The spaceship demo showcases many different effects which you can create using Visual Effect Graph. It's available to download using the link below. For this setup, I want to create an effect that helps make the console here look like it's damaged and malfunctioning. The scrolling texture here on the monitor is a good start, but I think we can use some Visual Effect Graph magic to give this effect some interesting, unique character. Let's create a new graph and make some sparks spawn from the console. We want the sparks to spawn somewhat intermittently, so we'll start with the periodic burst block and we'll set the delay mode to random and the count to 1 with a range between 0.5 and 1. In our initialize context, let's add a random lifetime block and set the range between 0.1 and 0.25. Let's also add a size block and set it to 1. In our output context, let's set our main texture as sparks and let's set the UV mode to flipbook. We'll then adjust the flipbook size so that the size matches our texture sheet. Then, let's set the color mapping to gradient map and make sure that our blend mode is set to additive. Now we've got a nice fiery spark texture. Currently, when our particle spawns, it's centered on the texture. But we want the spark to generate from the base of the texture instead, so let's adjust its offset. Let's add a set pivot block to our output, and then let's offset the y direction by -0.5. Now the base of our sparks line up with the console. Let's also add an orient face camera plane block, so that our sparks will always face the camera. This is looking pretty good so far. Our spark texture is spawning and aligned nicely, but we have 4 different textures we can use. So let's add a set text index random block to our initialization context so that there's a bit of variation between our spark particle textures. Finally, let's add some alpha and scale to our particle so that it bursts up from the console and fades out. In our output, let's add a set scale over life block and a set alpha over life block. We now have a nice-looking spark effect that bursts out from the console, but it doesn't really look that great on its own. To really sell it, we need to layer it with some other effects. One of the great things about Visual Effect Graph is how we're able to chain multiple contexts together to create layered effects. So let's extend our graph by adding some dynamic particles that will burst out from the console alongside our texture. Our current spawn context is only set to call for a single particle once. But for our dynamic sparks, we want lots of particles to be spawned. So we're going to need to create another spawn context. Let's add a single burst block and set it to random spawn mode. We want to have quite a few particles bursting out, so let's set the count between 10 and 50 per burst. A single burst block will only trigger once during an effect, but we want our spark particles to repeat whenever our main texture is spawned. Let's link the spawn event from our first spawn context and hook it into the start property of our second spawn context. Now, whenever the spawn event from our first spawn context is triggered, the spawn event on our second spawn context will also be triggered and keep them synchronized. In our output, let's set the main texture to spark single. Let's also make it so that we can see our sparks by adding a set lifetime random block, and we'll set the value between 0.3 and 2. Let's add some explosiveness by adding a set velocity random block and forcing our particles upward and slightly out to the sides like so. And in our update context, let's also add some gravity so that our sparks move a bit more naturally. That motion is much better, but we still need to do a bit of work on the visuals to make them look more like electrical sparks flying out of the console. They're pretty large right now, so let's add a set size random block and set their scale to be much smaller. Then in our output, let's change the color mapping from default to gradient mapped and set the blend mode to additive. This is looking pretty good now, but there are a few more things we can still do to make our sparks look really good. Let's add a bit more chaos to the particles by adding a set direction by speed block. This will spread the particles out a bit more based on their velocity. Next, let's add a turbulence block in our update context. This will add noise to the particle movement and make them look like they're bouncing around a bit. We'll need to add some mass to the particles for this to work properly. So in our initialize context, we'll also add a set mass random block. Let's fine-tune our noise a bit by adjusting both the drag and intensity over time. Let's create two sample curve nodes and hook them into our intensity and drag properties. Let's also add an age over lifetime node to use as our time sample. For our intensity curve, we'll start nice and high at 4 and reduce the value rapidly over time. For our drag curve, we'll create a very gentle curve at the start of the particle's life, peaking at a value of around 0.2. So this is looking pretty good. There's one last thing we can do to really add some juice to the explosiveness of the effect. Sparks often start incredibly long and fizzle out as they cool down through the air. We can simulate this by changing the scale of the particles over their lifetime. In our output context, let's add a multiply scale block and set the channel to just use the y-axis. Then let's set the value using a sample curve and an age over lifetime node. Our sparks should be nice and long at the start, but reduce down quite rapidly as they interact with the air. So in our curve, let's start with a value of around 30, and then set our tangents to drop quite aggressively and reduce the particle scale quickly over its lifetime. Currently, this looks a bit strange because the particles are oriented in a single direction. For this effect to work as intended, we need the lines to follow the direction of the particles instead. So let's add an orient along velocity block to our output context. We can continue to tweak their size and scale a bit until we get something that looks good. Now our single particles rotate to follow the direction in which they're moving and appear to cool down as they move through the air. Just by layering these two effects together, we've managed to create a great-looking visual effect for an electrical fault. But we could continue adding more layers into our visual effect graph and add more texture. For instance, if we really wanted to emphasize the explosion, we could add a layer of smoke that's gradient mapped to look like a small fireball bursting from the source. And we could also add a layer of smoke with an additive blend mode that bursts alongside our sparks. We could then add a second layer of smoke that's alpha blended and has a higher velocity as a darker cloud released by the explosion. By experimenting with different settings in visual effect graph like this, and layering different systems together, you can quickly and easily create great-looking visual effects for your game. For more information on visual effect graph and to get started crafting cool visual effects yourself, follow the link in the description below. Thanks for watching.